Okay, let's go over this lab. I just did the whole spiel on this and somehow I pressed some button and I erased the whole recording. So I'm just going to do it again. Alright, so this is lab 7. The lab number might vary depending on which class you're attending and which part of the time continuum. It could be next year, it could be 2 years from now. So this number could vary and this class description could vary, all right, because some of the labs are common to certain to different classes, same as if you're learning Ohm's law, you're going to learn in more than one course. Ohm's law is Ohm's law. So same thing with the labs. Okay. Now, right off the bat, I'm going to ask you to watch this video. It's a very short video which describes the final version of the product, the whole objective of why we are doing it. In a situation that's more similar to the real life example. Okay, just watch it. It's about 4 minutes. Okay. Now, over here, what we have done is presented a little bit of information about the equipment that you're going to be using during this lab. So, volume control. Here's the front view of this volume control. Here is the rear view of this volume control. All right, what does it say? Okay, so here's the model number of this particular volume control, and this particular one handles up to 10 watts. So 10 watts of power can go through the transformer that is at the back of the volume control. If you need uh, more power, then you should order one that handles more. Because, but this one here, 10 watts for our purpose is good. So, but I just want you to know that there are different volume controls that can handle, excuse me, more wattage. And sometimes you're going to have plastic faceplate, and sometimes you're going to have a stainless steel faceplate, depending. There are different manufacturers producing, but it's basically the same thing. All right, so at the back of the volume control, you have a transformer. It's not just a regular volume control like a potentiometer. The volume control goes in steps, so it's going to be click, 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 click. There's no smooth action. How you click that, it changes the taps of the transformer. All right, so the idea of the distributed audio is that at the back of the amplifier, you're going to have an output. All right. Now, different amplifiers are going to have different outputs, different types of outputs. So make sure whenever you're designing your own system, you just have to make sure that you have the correct outputs for your needs. This particular one has common terminal, and if you're connecting an 8 ohm speaker, you would connect the signal wire to that. So here will be one conductor and the other conductor would go to the 8 ohm if it's an 8 ohm speaker you're connecting to the amplifier. If it's a 4 ohm speaker, you are going to have common and the other wire will go to the 4 ohms. If you have an 8 ohm speaker, then you should connect to the 8 ohm output of the amplifier, and if you have a 4 ohm speaker, you should connect to the 4 ohm output. um, the impedances should match for the purpose of maximum power transfer. If you mismatch the impedances, then you're not going to have maximum power transfer. So not all the power that's being produced by the amplifier is going to go to the speaker. Some of the power is going to dissipate in as heat, and it could dissipate in the cable. It might heat up the cable, or it might, which is usually the case, it might heat up the amplifier. So now, what other outputs here? Here's a 70 volt and there's a 100 volt output. All right, we're using 70 volt output. Also, well, this 100 volt is not as common as the other one would be 25 volts. All right, but this particular one has 100 volts. What happens is that depending on the design of the system, um, you can have the two most common ones would be 70 volt or 25 volt. It's a constant voltage system, which means basically in the main audio line, so there's this wire here, in this wire there's a part of the cable. Right? If the system is cranked up to the full volume with the signal still being clear, not distorted, there is going to be 70 volt RMS on those two terminals, and the wattage that is going to be taken from the main audio line is the wattage that is labeled on each tap of the transformer. Now, this here applies to the transformer on the volume control and as well to the as to the transformer on the speaker station. On the speaker station, yeah, on the speaker station, as I know it's a little bit fuzzy, but you're going to have the real thing in front of you. There are taps. This is the low impedance side of the transformer, and this is the high impedance side of the transformer. Low impedance windings and the high impedance winding. The low impedance is usually 8 ohms because it matches the 8 ohm terminal on the speaker. The high impedance, which would be more windings on the transformer, is the high impedance side, and it's usually in the range of 1000, 1200, 1500, or so on. Right? So this high impedance, okay, look, here's the common wire that you don't change. It's just there. It's hardwired. These two are also hardwired. They're connected there. They stay there. Usually soldered onto the speaker terminals. Over here in this particular transformer, you have the spade connectors that you can unconnect that and tap it into this one, or unconnect that and tap into this. You always have just two connections because you're going to establish something like this, all right? And these two, that's where the taps are on the speaker station, and this is where the low impedance 8 ohm, just those two little short wires that are going to the 8 ohm speaker. Right? Now, depending on what tap you tap into, you're going to grab different amount of power from the same from the main audio line, which basically is the wire here. All right? Now, let's see where the speaker is. There it is. Oops, here. Okay. Now, on the well, different speaker stations are made by different manufacturers, and you will have different shapes of the equipment. So this particular one, I use particular a lot, the word today. Um, Colloquialism of the day is particular. All right, so in this one here, you have spade connectors. In some of the transformers, you're not going to have the spade connectors, you're going to have a bunch of wires that are sticking out, and you're going to have to choose which one to connect. One is going to be common, and the other ones are going to be color coded. In this particular station, you have a little bit of a legend here. And one of the rows is going to describe the 25 volt system, and the other row is going to describe the 70 volt system. So this can be used with a 70 volt system or 25 volt system. We are using 70 volt system, so in 70 volts you're going to have the tap numbers here: tap 1, tap 2, 3, and so on. And these are the taps: 1, 2, 3, 4, and so on, and they are labeled. You can't see those numbers, but once you have this whole speaker in your hand, you're going to see the tap numbers. So here's a tap number, here's a tap number: 1, 2, 3, and so on. And over here you're going 1, 2, 3, and so on. And on the bottom, or on the top, I think, excuse me, you're going to have the wattage listed. So if you want to tap this speaker at 1 watt, you're going to use tap so and so if you use 70 volt. You're going to use tap so and so if you use 25 volts. So you just have to kind of figure this out. I just explained that to you. So now pause the video a little bit, see the speaker, and figure it out. Right? So these are these taps right here. Now on this one here, I just listed 3 taps, but usually there's a little bit more on the transformer. Right? So there's a common, and depending on which tap. Now, what does it mean if you're going to tap the speaker, let's say for example 1 watt? Tap the speaker at 1 watt. Tap the speaker at 2 watts or whatever. Okay? This means if you tap the speaker at 1 watt, which would be one wire goes to common, the other one is to whatever the tap represents the 1 watt. That means if the whole system is turned to the full volume, you're going to have 70 volts. You're going to have 70 volts across these two RMS, and you are going to grab, that speaker station is going to grab 1 watt out of the whole main line. So here comes to the calculating of the system. How do you calculate the system? What do I mean by that? Well, if you have a system, the amplifier, because this transformer, this step-up transformer, which means there is low impedance, and here's a high impedance out. So these two terminals, high impedance, are these two terminals. Right? If the system is rated for 100 watts, which means it can handle outputting 100 watts into whatever is going to receive it. Right? That means you can connect 100 of those speaker stations if you tap them at 1 watt each. Right? Because at full volume, if you tap the speaker station at 1 watt, where are we with this? Here. If you tap that at 1 watt, at the full volume, this is going to grab 1 watt, which means you can connect 100 of those before you start overloading the amplifier. You don't have to. You can connect just 50 of them, right? But you can connect up to 100 of those. Now, if you tap each of the speakers at half watt, and this is capable of sending or of handling 100 watts, if you tap them at half watt, then you can connect 200 of those speakers and you're not going to overload the system. And so on. So this is how you calculate that. Now, general rule. Because sometimes, well, you might remember your high school years when you have the school PA system. This is a common thing for using the school PA system. You notice that there were hallway speakers in the ceiling and there were classroom speakers in the classroom. When it comes to tapping those type of systems, usually you would tap the hallway speakers at 1 watt each, and you would tap the classroom speakers that are in the classroom, like in the wall or on the wall. You would tap them at 1/4 watt. That gives you a proper volumes balance between the classrooms and the hallways if an all call page is made. So if there's an announcement that goes through the whole school, all the speakers that exist are turned on and there's an announcement. So then if you tap the classroom speakers at 1/4 watt, tap the hallway speakers at 1 watt, you got a healthy volume balance between one and the other. So the system is set up properly. Okay? All right. So let's just, I think we have, all right, we have covered this page. So notice the speakers are basically the high impedance. So here's a step up transformer. This is a low impedance, 8 ohms usually. It's high impedance, around 1200 ohms or 1500 ohms. And that is a step up transformer because it steps up the impedance. Now, this side of the transformer is this transformer is a step down transformer, which is This one here, step down transformer. Okay. Here's a high impedance, and here's a low impedance. Now, from other subjects, you probably have learned that what do transformers do? Transformers transform voltage, transformers transform current, transformers transform impedance. Here is the key. So you can consider this as an impedance matching transformer because you're matching this impedance with this low impedance with the high impedance. So transformers transform voltage, transform current, and they transform impedance. What do they transfer? They transfer power. Right? So if at this side you have a high voltage and low current, of course on the other side, on the secondary side, you're going to have the opposite. You're going to have a lower voltage and higher current. But, well, power equals voltage times current if it comes to RMS values. If you multiply them, you're going to have the same power on the primary windings and the same power on the secondary winding. That's the beauty of the transformer. Okay? So that's why we use them like that. Otherwise, if we didn't use the impedance matching transformers, we would have to use a combination of series and parallel connections in order to accomplish 8 ohms at the, and that is just not practical at all. What if you need to add one more speaker somewhere? Well, you have to redesign the whole system. What if you have 300 speakers in the whole building? Well, so that's why this distributed audio system was invented. You could just run one main audio line, and you could just tap in, tap in, tap in, which is basically you're making a bunch of parallel connections. Yeah. So that's about that. All right, this here is basically what I said. This is what I said already. Okay, let's keep going with the pages here. Now, what we are going to do in our classroom is this main audio line is already pulled through and it's installed in our countertop in the main and right in the middle of that middle raceway. Right? And you're going to have those taps. Uh, every classroom station has the tap pulled out. I'll show you in the further images there. Right? So you can keep connecting. If it's a bunch of hallways, what if you have a side office somewhere halfway down the hallway, and that person wants to be able to control the volume of their own speaker in their own office? Well, you can do this. So instead of connecting the speaker directly to the main line, you're going to connect the speaker through the volume control. And the connection is very simple. You run the same as you would be tapping in with the the speaker station. You tap in to the main audio line and you run that line into the input of the volume control. Then you grab the signal out of the output volume control and run it into the speaker station. Right? Where's the input and output of the volume control? Here it is. Here's the input of the volume control, and here's the output of the volume control. Here's the common. Here is the signal, and here's the signal. Signal coming in, signal coming out. Signal coming in, whichever tap you choose on the speaker station. How is the tap being chosen on the volume control? Is by rotating the dial. It's a step kind of a thing. So you rotate. There's no smooth action here. It's a click, 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 click. It's a selector switch that selects a tap. Right. Same principle, but over here you insert it manually and leave it like that. And over here you can choose the taps by dialing the dialing the volume control here. Okay. So that's what we're going to. That's what we are going to do in the classroom, and we are going to do it in a specific way. Now, if you just have that schematic right here that you see in front of yourself, you could improvise the connections, and you're going to make it work. But this would work if you are connecting this sort of a system on your ping pong table in your basement. But that's not what we're going to do. What we're going to try to show you, what we will show you, is a procedure that is being done, excuse me, on the job site in order to make things efficient. Right? So let's just analyze this here. Here is the location of the main feed, which would be maybe on one end of the hallway. Then you're going to run. It's going to be a box. The wire just continuously pulls out as you pull on the wire, and you're just going to keep pulling and run it right in the ceiling space, right to the end of the hallway, and you're going to tie it to somewhere, and then you're going to start pulling the service loops. Wherever the ceiling speaker is going to be, you're going to pop the tile, pull down the service loop, tie it, pull down the service loop, tie it. So the loop can be hanging, but you're tying the base of the loop. And so on, and you work your way towards the beginning of where the wire box is. So you keep pulling the wire from this side, and over here things remain as you left them. Right? And you're going to leave those loops. So there's one person does that. While that person does that, there's another person at the same time preparing the pigtails for the speaker station. So you're going to connect maybe 20 feet or 15 or 10 feet of wire as you're required into the speaker station, and you're just going to leave it there. And you're going to maybe place it on the floor where the ceiling speaker is going to be. So one person does this, the other person does that. Once you have all done your job, then each one of you is going to grab a ladder and connect those, because there's going to be interruption here, because that's going to be the if you can, sorry, back up a little bit. If it's just the hallway speakers, you're going to just connect those that loop into the speaker and put it up in the ceiling space and coil the remaining wire right nice and neat and tie it to some ceiling structure, usually the I-beam or some kind of a steel structure there. Do not tie it to the rods that support the drop ceiling. Why? Well, wires should not be tied to the rods that support the frame for the ceiling tiles. It has to do with the fire and safety. God forbid there is a fire, but sometimes there is. And when the fire crews come in, they sometimes need to pull the ceiling down or whatever in order to control the fire, and they use those those sticks with the hook at the end. I'm not sure whatever they are called, and they're going to keep pulling the structure down. If there are things tied to that ceiling structure, it's going to put them in some sort of a danger of getting hurt. So that's why all the cabling right now that's being run in the ceiling space should be independently suspended on their own structure, tied to the ceiling hard structure or to the walls, not to the rods that support the frame that supports the ceiling tiles. Okay. All right, so that's basically how things are being done. In the beginning, watch that video, that 4-minute video. Watch it. It's going to give you a little bit more picture here. All right, let's see the objective of this whole lab. The objective is to connect the speaker station to the main audio bus. The audio bus is the main cable that is right in the middle of the right in the middle of the island, and they are tap outs already pulled out for you, so you can use them. The speaker must be connected through a volume control. We're going to create this scenario here through a volume control. All joining connections are to be in the ceiling, and there's an asterisk there. What did I write here? During this exercise, we will make all the connections on our countertop space. So we're going to have a pretend ceiling space and pretend wall space. Where is it? Well, let's see the final picture here. There we go. Yeah. All right. So see that dotted line right here? This is the wall, pretend wall, and this is pretend above the ceiling tiles. Right, so all these connections are going to be made and tucked in a nice, beautiful service loop. So when you have to come back 2 years after your installation, and if you need to service the system, you're not going to look for connections all over the place. You're going to have that nice and neat service loop where all your connections are being done. Efficiency, all right? Uh, so that's what I'm saying here. Um, this speaker station, while one person is pulling down the loops from the ceiling tiles, the other person connects that and has a length of wire just ready to be connected. Right? So then the other person is going to prepare whatever the connections in the ceiling, they're going to be left hanging there. And once everybody does their job, then the two people get the same, do the same job after that, which is basically grabbing a ladder, making the connection, and tucking the ceiling speakers right into the ceiling. Sorry about that. I just hit my microphone with my hand. Okay, so I'm just going to, well, I'm jumping between pages here. Here, here. Let's go to the top. Okay. The volume control is to be wall mounted, asterisk, the pretend space mode. Watch the video, that's what it looks like in real life. The video on top there. Uh, one coil service loop with all the connections must be made in the ceiling. That was the service loop that I was showing you just when I was showing you the final product. During this exercise, we will make all the connections on our countertop space. That's the asterisk. Here, that's the asterisk. Okay. Now, this picture here is before we had that main line pulled. We were pulling the main loop ourselves, and we were pulling down the loop. So in the real life, this is the wire that you pull into the ceiling space. You tie it at the end, and you just pull a loop, and pull a loop, and secure it. Pull a loop and secure it. Pull a loop and secure it. So you work your way towards the box of wire, right? Obviously, because you're just gonna keep grabbing the wire out of the box, and whatever is behind is going to stay untouched. Okay? So you're not going to do that. You're going to have that. Well, this is a couple of years ago or a few years ago, before the main wire was pulled in, and this raceway doesn't even exist. It did not exist then, right? But now it does. But I'm just showing you this how it's done in real life. This is in the ceiling, and that's pulled down to the floor. Okay? The end of the run, before the whole system is turned on, make sure you cap it, because if you don't cap the main line at the end, you're going to run into a danger of the possibility, or you're going to run a risk of those wires shorting out. They could touch some metal surface or something, bang, it's shorted. Right? So always secure the end of the line. Over here, this is the main loop, and these are the two more lengths that are you going to run into the yeah. Come on. Those two lengths you're going to run into this conduit, which is the pretend in wall conduit, and you're going to have to label them, because in the real life you're going to have a box in the wall, because there's going to be a box, utility box out here. It says attach single gang utility box here, and that's where the volume control is going to go. You're going to have two wires sticking out of the box, and you're going to have two wires basically sitting in the ceiling space. Which is which? Label them in a way you understand. Sometimes you might want to label 1, 2, and 1 and 2 on the other side. That's coming out, so you know which wire is which. Or you can label it as to the input of the volume control. You can write the whole thing with the magic marker on the wire, or input, output, whichever way you're going to do it. It should be in a way that you understand which cable goes to which terminal. Right? There's no rules, unless those rules are going to be set to you by whoever is hiring you to the job. They might want it done a certain way. All right, let's go back to where we stopped. All right, so that loop is going to be interrupted and joined right back together for the purpose of adding one more wire to it, and that's the wire that is going to go into the volume control. Where is the system that we had? Here. We're cutting that loop and we're joining it back together, and we're adding a third wire which is going to go through the conduit into the input of the volume control. And then from the output of the volume control is going to go back. It's going to end up in the same service loop, but it's going to be connected only to the primary side of the transformer. All right, let's keep going with this. So that's, cut it, strip it, strip off the jacketing, and well, strip the insulation, and make a pigtail. Right. Your lab instructor is going to show you how to make a pigtail if you don't know. So here's the stripping part, and it should be joined together. See all the wires, label them, label them, label them, label the wires wherever you can. Then you're going to equalize the lengths, because if you equalize the lengths, it's going to be so much easier for you to coil things together. Right? And this is the right here. There are 3 wires. The third wire is hiding behind these 2. Right? And the third wire that's out of there is going to the input of the volume control, and this wire here is coming out of the output of the volume control. And you see it's cut here, and it's going to be joined with the pigtail that was prepared by the other person, while the other person was, well, the first person was pulling the loops. So that's why in one of my notes I said that can you just run a wire straight from that output and without having to join it, just straight wire? Yes, you can, and it's going to work if you do it on a ping pong table in your basement. But we're trying to give you the procedures so you can be efficient on the construction site. This is how it's done efficiently. Right? Here is the volume control. One thing I'm going to point out to you: when you strip the wires, have these stripped lengths, and notice over here, those lengths are equal. Maybe these jacketings are not equalized to the millimeter, but when you join those together, when you tie them together with a zip tie, those at the end physically should be the same length in order to not make a mess. All installations should be done neatly. Neatness, neatness, neatness is a lifesaver when it comes to doing big jobs with many connections. If you don't develop a sense of neatness when you're doing a job which involves many connections, uh, you are going to run yourself into some sort of a trouble of not being able to figure out what you have done 2 days earlier. And you're going to do that mistake once, and from then on you're going to start developing more neatness with every job that you're going to come across. I just want you to be aware of that. Right? Now, the length here should be long enough and short enough. What do I mean by that? What I mean by that is when you put those wires, insert those wires into the screw terminals, the strip length should not be too long, sticking out, so when you move the whole device, you don't want them to touch. Right? Let me just show you the first page again here. Bear with me. There you go. See, those wires should be stripped. So once you fully insert them inside those screw terminals, they the insulation should be just pretty much almost touching the housing of the screw terminal. If the stripped wire is too long, then you're going to run yourself into a risk of those touching unwantedly. And if those wires touch, you know what happens? They short out and you get unwanted connections. Right? Now, they should be stripped not too short. So once you shove in, the insulation should not go into the screw terminal, because if that happens, then you're going to make a connection with the insulation, not with the bare copper. And I believe there is a position on the rubric that you're actually going to be evaluated on the neatness of this connection. This is extremely important that you do a neat job when it comes to this. Don't have any frays, because that's a stranded wire, so you don't want any of those wires fraying with some strands sticking out and possibly short. Make them nice and neat. Twist them so they stay in one place. The whole conductor stays in one stranded place. It looks basic, so it looks like almost like a solid wire. So there's no loose pieces, you know, possibly touching. Okay, what do we have here? All right, you're getting the whole run on this lab. I'm going to point out to you this. You should read that at least once, and you should watch this video at least once. Few minutes out of your life. This is eight. These are 8 pages. This lab material, all those sheets, it consists of 8 pages. Well, when it comes to the real life and doing real projects, you're not going to get documentation consisting of 8 pages. You're going to have a documentation consisting of 300 pages. And inside those 300-page document, you're going to have details that you can't miss. So basically, you're going to have to read very carefully. There goes your weekend before you're going to do the job on Monday. Now, the good news about that is that it's not happening all the time. It's just whenever you get a new project. Now, if it's just a one-time project, yeah, okay, well, you might complain a little bit. You know. But usually what happens is that the company that you'll be working for, or if you do your own business, you're probably going to get a project that you're going to have to repeat a few times. Usually it works nicely with some big chain companies. Don't want to mention any names, but they are chain franchises that once they choose a company to install their systems, usually they stick with one company because they also understand that it takes a little bit of time to learn to do the system for the first time, and it might take you actually twice as long to do the first system that you do, because you're going to have some questions, you might going to have to clarify them, whatnot. Right? But then once you do the first one, second, and third one, then you don't have to read all the 300 pages all the time. You might kind of go back and pick and choose to fish out some details about certain setup of certain device, if you don't remember exact connections, or sometimes what's involved is the programming of certain devices like cash registers or money machines, and certain type of terminals, right? So this the network cabling course is not just about running a cable from point A to point B and connecting it. It takes a lot more. It takes modem excuse me, it takes setting up modems, it takes setting up and a lot of other things, switches, controls, and whatnot. And usually also don't be intimidated by what I'm saying right now, because usually when it's complicated equipment that is being set up, you can't set it up yourself. During that setup, you could be having your laptop connected to whatever switch or equipment, and you'll be on the phone with the technical support of that particular company that has set up the system. And sometimes sometimes you can't do it by yourself because you need all the passwords and all whatnot. So basically that's what's involved in this job. So 8 pages, that's nothing, right? All right, enough of the storytelling here. Let's keep going. I believe we have stopped somewhere here. Interrupt the loop. Um, Connect two wires which go into the conduit, goes to the conduit box. One of the wires goes to the input of the volume control, which is will be the one that's connected to this. Right? That's a pigtail. It's going to be consisting of 3 wires. It's cut and it's joined back together with 1 wire added. Right? And the other wire is going to come out of the volume control, of the output of the volume control, and that is going to go physically to the same loop, but it's not going to connect to anything else but to the pigtail that is coming out of the speaker. Equalize the length, label things, please label things. Look, this is the same. This is the beginning of the loop and this is the end of the loop. In, out, in, out. I label them that way. You might label them a little bit different. You can use in from the amplifier, out to the field. You might write that too. Okay, or sometimes you're going to have certain other labels done in a specific way that is going to be specified by whoever hires you to do the job. Right? But label wires at both ends. Label, label, label. Also, we need to see those labels in the photographs that you're going to provide, and you're going to also be evaluated on making those labels. When we evaluate you on the labels, it's not that we want to see exactly what's on every label. We just want to see that the labels are there. If we don't see the labels, you're going to get marks deducted. All right. So in the real world, um, you're going to okay. I'm trying to demonstrate the neatness of things. When you have 2 wires run to the same place, make them the same length. It's easier to coil them into the loop, and once you have to troubleshoot and undo the loop, it's so much easier when you don't get yourself into a tangled mess. Right? Neatness, again, neatness, extremely important. I can't say it enough. Right? So in the real world, that's what you would have. Here's the third wire. Actually, that's where we stopped last time. Right? Um, that's where we stopped last time. Oh, I'm repeating myself here. So here's the um, here's the main loop interrupted and the third wire going into the input of the volume control and brought to the same point. See, lengths are equalized, nice and neat, and that is going to be butted together with the wire that is connected to the speaker station. All right. And at the end, when you have done nice and neat job, okay, how long is this cable should this cable be? Well, varies. Usually in the real world is 10 to 20 feet. So that's this cable right here. So once the whole thing is tucked into the ceiling, you have the freedom of or the comfort of placing the speaker station where it should be in the ceiling, or if you need to relocate it a little bit, you can, without having to interrupt any of the connections. Right? And once everything is done nice and neat, it's going to be coiled into one service loop with all the connections being done nice and neatly. This is the pretend wall space. This above the dotted line here is the pretend ceiling space. So that's why we can do the pretend wall and ceiling space. Watch this video that is on the very top of the document. There's a link to YouTube video about 4 minutes. It's going to show you this system in some sort of like a real, closer to a real situation. Right? We're showing real ceiling and real walls. All right, notes. The taps on the speaker station transformers are hardwired. We talked about that. Um, Taps on the volume control. We talked about that. On this diagram, only 3 taps are shown. Here's the notes. Let's go back here. Uh, I can only show. I'm just showing 3 taps, but usually there are more. Right? And some of the transformers are going to have the spade connectors with two wires. This is nice and neat. And some of the transformers are going to have wires sticking out and color coded. And on the transformer, you're going to see yellow for 1 watt, orange for half watt, or so, I think whatever the color are going to be, right? So they're by different manufacturers, the things are being made in a different way. Let's go back to that note here. Um, on this diagram, they only show 3 tabs. Number might vary depending on the manufacturer. Note number 2, the input of the volume control could be connected directly to the main audio line while using only one additional cable length instead of the two. What I mean here is out of the volume control, can you just run a wire straight to the speaker? Yes. But again, as I say, it's going to work, and you can do that if you are doing this project on your ping pong table at home. But nobody's going to pay you for doing this on your ping pong table in your basement. We're trying to show you the procedures. So that's why you're going to have one wire here cut and one wire here cut, and you're just going to join them together by the wire nuts. So basically that's what that note says. The input of the volume control, the input or the output of the volume control, that should be output here. Okay. I have to change that. We connect it directly to the main audio line without using any additional voice string instead of two. This would work, okay, like on the as a project, but we're trying to give you the scenario of what you will be dealing with when in the so-called real world. The point of this exercise is to introduce the idea to the real job site environment where tasks are done in stages and the final product is clearly defined, repeatable, and serviceable. Right? That's the final thing. Now, deliverables. Right? Deliverables. We're going to ask you to take 3 pictures. We're also going to mention that we are practicing following the instructions when it comes to the deliverables. Is there one set in stone format for all the deliverables? No. How the deliverables should be presented will be decided by the company or the person who hires you. Thing is that every project these days, what you do, you're going to be asked to produce photographs, and those photographs are going to be asked that they are in a certain way. So follow the instruction to the T, because if you don't give them the deliverables, if you don't supply the deliverables or submit the deliverables in a way that you're being asked, the deliverable documentation might be rejected, and it might result in a delay of payment, or you're not going to get paid at all. Very rarely, but usually create friction. Right? And if things are being done and smooth, nice and smooth on your end, there's a bigger chance of you being hired for the next project and for the next project and for. But if you cause troubles, like if you're being creative, if you are creative with the deliverables and you give them not the way you're being asked to, well, they are going to call somebody else for the next project that basically follows their instructions. All right. So that's as far as that. So we're going to ask you to take 3 images. I just put just that kind of an angle. Of course, this is going to be the speaker station with the wires connected. I just didn't want to take the picture like that because so I don't want you to copy it and present it as your own. So you're going to have it from this angle. What do we need to see? We need to see the cable labels, we need to see the zip ties, proper pigtails, and correct tapping. If you take the picture in a way that we don't see all those things, you're going to get the marks deducted as if they did not exist. We're so mean. Another picture is going to be taking the volume control from the rear side. So we're going to take it out of the box and take a picture of that. And what do we need to see? We need to see cable labels. We need to see clear view of the screw terminals, connections. So we need to see that if this bare copper wire is not too long, if the insulation is not being pinched, if you present the image in a way that we can't make out the image, then you're going to also get your marks deducted as if they were done wrong. All right. And then you're going to take a picture of the service loop. Remember when I say, okay, we need to see the pigtails, nice and neat pigtails here, not all over the place. Zip ties, we need to see the zip ties, cable labels. Well, we are not going to ask you to spread those cables so we could see every single label if it's correct. No, we just need to see that the labels are there. Okay? That's all we need. And neatness. All these things you're going to be evaluated on, and if you present the photograph in a way that those can be seen, it's going to be treated as if they are done wrong. All right. Pages of the deliverables. First page, work order. You have done that. You know what to do. Okay, this is the last lab that you're going to do. Well, some depending on the class, it could be the first, but that will be explained to you before you do this lab. Right? In fact, most of my class, all our classes are practicing the deliverables first, so you know what to do here. I'm not going to explain. Um, and then the second page, three separate tables. Table 1, separate table 2, separate table 3. On top of the table 1, you're going to see the first image, second image, third image, and on the bottom row of each table is going to be a description. Do it the way you're asked to. If you practice following the instructions properly, trust me, you're going to have much easier job when you go to work in the real world, right? Because that is a standard. It's not going to be necessarily done in this specific format, but you're going to have to pay attention to what you're being asked to deliver. All right. And this is the description of what we need, which is what I just said. All right. Um, well, that's pretty much it as far as explaining this lab. And I will see you in class. Take care, guys.